Well, Willow told me that I had incorrectly told you guys about the types of tubes and how they were, so I have to make a correction today and get it in there, which I will do. I'm going to get that correction put together. Willow, what do you got to say? How did you find that? How did you find that I said the wrong tube? I said it was a triode and it was actually a diode, and you made fun of me last night because you said, Dad, you don't have a clue what you're talking about. But I'll get it fixed, okay? I promise you, I'll fix it today. I promise you. All right. You still not gonna fire me, right? All right. Thank you. Bye-bye. Well, hello. This is John from Indiana. Welcome to Radio Hound Tube Radio Restoration. Today's class is going to be on continuing on the power supply, showing how the B plus after it comes out of the rectifier can move through the radio. You need to know that because there's a lot of times you have to troubleshoot that when you start a new radio and you've done your recap and you turn it on and something don't work right. You have to know where it's going so you know how to try to trace your problem. So I hope you'll enjoy today's class. I do have a little video that I'm going to put right in the front of this that is going to show you a mistake that I made, and I'm making a correction, so I want you to pay attention to that, and then we'll get right on into the video. I hope you have a great time. Okay, before I start today's video, I want to make a correction of something I said the other day on a video. I incorrectly referred to the picture that I had of the filament, the cathode, and the anode or the plate. I referred to that as a triode. The filament does not include in the tube count of the parts of the tube, and so what that should have been when I said that. I saw this when I was reviewing my video before posting, but I should have referred to this as a diode. Most of the time you'll see these in the rectifier tubes. You'll just have your cathode and your plate or anode. All right, so that should have been a diode, not a triode. A triode adds in the grid line. So you have a cathode, a grid, and the plate or the anode, and that's three elements inside this tube. You got the plate, the cathode, the grid, and the plate. So in this grid, when you just have one grid like that, it's called a control grid. And I'll explain what the grids do on another video. Today I'm just making the correction. Then if you add in the second grid in here, you have the cathode and then the control grid. These count from the bottom, so the control grid's always on the bottom. The next one coming up, if you have a second grid line in there, it's called a screen grid. And then you have your plate at the top. And then that's called a tetrode. And then lastly, well, it's not lastly, but lastly for us, I'm going to go up to 3 grid lines, but you have control grid, you have your cathode, your control grid, your screen grid, and then the last one on this example is called the suppressor grid. And then you have your plate or anode, and that's called a pentode because it has 5 elements, 1, 2, 3, 4, 5. So this is a correction I needed to make because I incorrectly referred to this one over here as a triode, and it's not. You do not count the filament in the count of the parts of the tube. So I just want to make a quick correction. It has nothing to do with our video for today, but it will help you to, when you look at a schematic, kind of see what you're looking at, and maybe we'll point that out when we start looking at our schematic. All the stuff I'm bringing up right now is just helping you learn how to do schematics. When we actually start on our radio, we'll start back from the beginning, and then you'll see what our radio does versus the things that we learned during these classes. So I hope all this will help you, and I hope you enjoyed today's video. Today's video, we're going to be looking at how B plus moves through the radio and on the schematic, and that'll maybe help you to understand the flow of things, and then we'll start on the sections after that. Thank you very much. We're going to start off today's video with talking a little bit more about the power supply. We have to finish that up today. The power supply feeds a lot of places in this radio, and I have marked a few of them, but the highlight in the pink is what we're going to be talking about first. That's called your B plus radio, or they call it your B plus. People, when you hear referring to B plus, they're talking about the voltage that comes out of the rectifier here. Remember we talked about coming out here at the cathode, and let's just say that's 350 volts or 400, you know, something like that. That'll be coming out there. That's rectified DC coming off of the cathode that's right there, and that's coming out. We're not going to talk anymore about going through the electrolytics and doing the filtering and stuff like that. It goes into the field coil, which is, remember, it's on the speaker. Then it comes back in from the speaker and goes out here on this line. Okay, this line goes to a few places. The first one, it goes to the candom resistor. The candom resistor has, in this case, it has four places. And as we're going here, say we got the three, well, it's going to drop down a little bit over this field coil. So let's just say it's 3 something on the other side of here. Okay, that's what that voltage is going to be here. And then each of these, let me zoom this in here. Okay, each of these resistors they're all interconnected in a series. They'll drop that voltage down a little bit on each point right here where you got the dots, and pretty soon it'll go clear to the zero. All right, but each one of these will have a different voltage at this point, but each voltage should be less as it goes down the chain here, okay? Then we go on up, and the next place it connects is it goes over, well, let's talk about this candom first. It goes in this first section, so that means you're going to drop some voltage across the resistor. Anytime you go through a resistor with voltage, it's going to lower that voltage a little bit. It might not be much, but it's going to lower it. And when we actually get into this radio here, we're going to actually figure out what that amount is. We're going to put a multimeter lead right here and a lead right here, and we're going to see how much voltage that is. And whatever voltage that is, that's what they call your voltage drop. So if that's 350 here, it might be 325 or 300 or whatever right here, because some of these tubes up here, so let's follow this one then. This line, there's nothing in the way, nothing in the way, nothing in the way, and then there's another resistor. Okay, whatever that resistor is, it's going to drop the voltage a little bit more, and then it's going to bring it down, and then it's going to bring it up to this 6F5. Well, on average, a 6F5 needs 250 volts at the plate, and that's why I'm kind of guessing that our voltage is going to be at least 350 coming out of here, because it's got to do all these. It's got to do the drop here, and then it's going to have to do. The. I lost my place here. Sorry. Okay, I'll get it straight here in a minute. It has to do the drop here, and then has to do the drop up here on R16, and then it finally makes it to the plate. So you're going to drop some voltage on that resistor, and you're going to drop some voltage on this candom resistor. And that's what we're doing, is we're manipulating that B plus, and we're using resistors to get us to the point where we need to be. All right, then we go on up this chain, and there's another line. This line comes out here, and it goes all the way across to here. The pink line goes up. Now we're going to run into a resistor. So that's going to drop the voltage. Now see, we're still over here on that line. We're still at the full voltage for whatever comes out of that field coil. So, but when it follows that line up here, it's going to go through this resistor and drop, and then it's going to go up through here, and actually it goes through the coil. I drew that straight through there. It should be like that one. But it goes through the coil and then over here, so it's going to drop just a very little bit on this coil, and then it's going to go into that plate. This particular tube needs around 250 volts to operate good. All right, then if you go on, it also runs over here and feeds this tube the same way. It has another resistor like that one that's in the path, but this also has a little coil that's going through too to equal to that coil. And then it's going to go to the plate, so it's going to need around 250 volts. So these two are being fed by this line. Well, also, I'll come back to the green line in a minute. All right, then if you look at this one, you're coming out on that same line. There's a dot right here. It goes up and it goes through there, and so it's going to have just a little bit of drop So more than likely this one probably, because this 6K7 can take up to 300 volts, so it might be a little bit higher voltage right here. And then when you get into the detector tube, and that's a whole another story in itself, and when we get to the sections I'll try to describe that. But when you have a detector tube, you're needing that detector tube to be very low in plate voltage. And as you can see, this plate voltage goes down here, and that goes to that third section, so it's already dropped the voltage here, here, here. And you know, I'm gonna guess that this voltage right here will probably be 50 volts or less on that plate coming out of there. All right, and then the next one that you're going up to, it's fed. Oh, we already went over the 6S5. So the next one coming off the 6S5, there's a when we went to that plate, well, there's another tube called 6J5, and it drops down through this resistor. So it has where it comes up through here, it goes down through this resistor and then over to the plate. This one needs around 200 volts, so this probably is a good size resistor to drop that down. And then your other one that runs straight up here, and we talked about this one I think on the last video, is it goes in the center tap here and it goes both ways. That 350 or 325 volts, whatever's going there, that's going to go through that coil and then down into the plate here and through the other half of the coil and up to the plate here. These are tubes that are exactly the same, twin tubes. They're 6V6. But anyway, those tubes need to be between 250, and actually it goes up to 450 if it needs to. These tubes can handle the power and the heat really well. Now, that's all the pink lines. That's where you're feeding your power into the plates of all these tubes. All right, now we're going to go on the green lines. The green lines is where we're feeding power into other places. And we're still using that B plus power, but we're not feeding the plates, we're feeding other things. So when this one comes off of here, off of that second, it's going to drop the voltage here, it's going to go up here, it's going to turn left, and it's going to follow the green line out. And look at here, it's going to the grid of that same tube. So it's going to the plate and the grid, but it's coming from two different locations. So that means you're going to have two different voltages. And I'll explain, I can tell you this, the grid voltage is more than likely going to be lower than the plate voltage most times. And then like this green line is coming off the end of that hot line, and it's going up also to the grid. So, and there's another drop in voltage right there. So they're using resistors all over the place to bring the right voltages to the right area. And then to have a B plus rail, you got to have a B minus, because you got to complete your circuit. You know, like on any electrical circuit, you got a positive and a negative. And most of these guys come out to ground on theirs, but there are some that return back. And there's certain areas I'm starting to shake again because I got this thing zoomed out. All right, I'll roll it back in here. All right, or zoomed in, I should say. All right, so I'll zoom back out and try to just go over this last little bit. But the B minus rail, like you bring it back, and the B minus is where you're returning back so you can have the full circuit. Okay, so this is the negative end. This is the positive end of that can dome. And you can see all this stuff. Remember we said our negative stuff goes out here and it goes up to the can dome. The can dome's kind of like the director of all this stuff. And it'll help you get all your different voltages that you need throughout the radio. This is not all inclusive. This is just a quick overview of how all the B plus moves to the radio. But you got to know, okay, if I'm getting that, if I'm only getting 50 volts right here where I'm supposed to be getting 250, now you can know where to trace that and see what's wrong. Maybe one of these resistors are bad right here, and you can trace it right back to where your B plus starts right here. We're coming out of that rectifier at the cathode. You can trace it back, but now you know kind of how to trace that to say, okay, it's somewhere in this line, something's going wrong. Either got a bad resistor or a bad connection or something, but I'm not getting my 250 volts here. I'm only getting 50 volts or something like that, or I'm getting maybe way too much voltage, because there could be other things wrong in the can dome that's not doing its job to drop your voltage like it should or whatever. So you it helps you to troubleshoot, but you got to know the path for the B plus and the B minus, and also where the other things, and there's more. I just highlighted a few in green, but there's other ones where it's still connected to that B plus and it's feeding like it uses a series of resistors to drop voltage into certain areas that need voltage. I mean, you got this whole area down here. The one thing I didn't even talk about when I was talking about parts on the radio, and I was pointing out the actual part versus the schematic. This is always a schematic picture, and usually it's roughly in the middle here in this area, but there are a lot of radios where they have the volume control up on the front end, but this is your volume control. And on our particular radio, remember, our volume control and our switch is on the same shaft. It's on the same potentiometer, okay? But a volume control, you can always tell. Let me zoom in on that and see if I don't shake too much. But this is your volume control, and you always see a little line somewhere on the middle of that, and it have a little arrow, and that tells you that it's movable. This right here, that's where you're moving that back and forth on that. But if you see a bunch of things like a large resistor, and then you see a little line coming in with an arrow on it, more than likely that's your volume control. And usually, like I say, usually it's right in toward the right end, but it's more center bottom, like down in here somewhere. Sometimes it's on up and right in here. Sometimes it's sitting sideways right up in here, but it's usually right around the detector amplifier tube area where they drop that in. Now there's like I say, a lot of models that have it on the front end too, which I don't like. But anyway, your volume control's here, and then if you go down here on that plug when we first saw it, that little thing is your switch. But both of those two things, that thing and that thing, are all on the same potentiometer. So see, it's kind of confusing because that's way down here and that's way up here, but it's actually really electrically on the same spot. Now they don't touch each other, they're just hooked together on that actual potentiometer. They're not hooked together electrically inside that potentiometer as two separate things on one shaft. But they can control both things from the shaft because it can have a snap switch which turns the power on the switch, and then after that it can be a rotational switch which changes the volume on the radio. And so they did it all into one thing. So when you're looking at a schematic, you look for that volume control, and probably more than likely on the back end of that volume control, I don't know if I got one here. I don't think I got one with the snap switch on the back, but yeah, I don't. But the bottom line is, you don't want to get confused by that. When you see that volume control, more than likely that switch is on the back end of it most of the time, and especially on the Zenith. So, all right, so this is your pink is your B+, and that's how it feeds everything. The green is B+ also, how it feeds other things besides the plates. And then your orange is your B-, and there's other parts of B- that comes into that too. But they always end up filtering back either to ground or back into this candome on the negative end of the candome. But that's how you can see how you complete your circuit. So this is how your whole power supply that I've got in these three colors, that's most of your power supply through this whole schematic. And it'll sure help you to troubleshoot and how to work on your radio once you get it fired up, because power problems is the hardest thing to work on. Because think about it, I'm gonna bring that back out so I'm not shaking so bad. With power problems, you can't even, when you're trying to turn something on up here, you can't turn it on because it's going to short something out. Your light bulbs are glowing and whatever, and so you don't have a split second to try to figure out what's going on. So you have to try to analyze your steps going through and checking all the wiring in all these areas that I got highlighted. You got to go through and make sure nothing's touching each other or whatever. Just another little side note, has nothing to do with this power supply directly, but it does have to do with this circuit right here. This is your filament supply for all these tubes. That's the part that well, let me do it like that again. That's the part that heats that little plate we were talking about. Well, this supply down here is what feeds that. Hit the little arrow going out, and you can see the little arrow coming in on each one of these tubes. Anyway, a lot of times if you plug this in and your light bulbs here glow real bright, I mean like really bright, like you're only turning up a few volts and all at once your light bulbs is blowing out real bright, more than likely, I'm just saying, a lot of times, I'll put it that way, there are many times when that's not true, but what I'm getting ready to say is a lot of times you'll find that you've got something wrong in your filament runs, and it has nothing to do with what I'm showing you here on the B plus going to all these spots here. Most of the time, if that blows up real bright when you first turn it on, start checking your filament runs, all your filament wires that go out to each one of these tubes. I would verify all the filament wires, because when you get it real bright that means you're pulling a real high amps, and remember, if you have low voltage, you're going to have high amps. So this is 6.3 volts. And it could be this filament line too, but that's a real easy to trace because there's only 2 wires. But this, you got wires going to 2 wires going to every one of these tubes out here, and you got 10 tubes in here, so there's a lot. And I'm not even counting the I think this one has I can't remember. Maybe it doesn't have a magic eye. I can't remember. But if it has, sometimes you have a magic eye tube, and it'll usually sit down in here. I don't see one on here, so probably don't. Bottom line. I wanted you to understand how when we got our 300 and some volts coming out of this rectifier, the flow. The pink is where it goes up, and the pink and green where it goes up, and the orange is kind of where it comes back into here. And then, like I say, our negative stuff meets it here to the back end of these 2 electrolytics, and the negative coming off of here, the other half of that 350, the negative humps are all going right here. So all that's landing back in here. All right. Things that'll confuse you too, and this is unrelated to the class today, but just while I'm sitting right here and spending a few minutes, when we figure out where our line is going to the negative, and that's what this line is right here, then when we figure that out, you want to keep in mind, this is the positive end of electrolytic, and this is the negative end. So you would think, well, maybe this is coming, this over here, this high voltage is coming across here and into this area. No, it's not, because it can't pass through, DC can't pass through these capacitors. And that'll help you when you're tracking this. See why I stopped right here? Because I know that DC can't go through that capacitor. I stopped right here because we're going between the 2 capacitors. I can't just say it went up some other way, like straight across. Just like I incorrectly drew that across here, that should have been around here, because those are capacitors. DC can't travel through capacitors, only the AC. And what the AC is that's going to travel through there is your sound, your RF that's coming through. That's the AC that's going to pass through there. The reason they have these is you have a plate here that has 250 volts. Well, if that 250 volts could come across that capacitor, and then it's going to go in to something else that might burn something else out, because these grids can't handle that kind of voltage. The coils themselves will do the same thing as the capacitor, and so it'll block that 250 volts from coming across there into this grid. These grids will burn up if you were to send that 250 volts. See the capacitor stopping right here, and then it goes into the grid. So your high voltage will stop right here, and it can't get into that grid. Your grid is fed by this stuff coming up on the other side at the low voltage. All right, so I've probably beat that enough. That'll be probably enough for today's class. I just wanted you to kind of understand the flow, and then next time we're going to go and we're going to start on this left side and show how it hooks up, and then how it moves through this radio, and we'll take one section at a time, and we'll make sure we understand that. And then when I get the sections all done, then I'm gonna go back through and just make sure with our radio, we're gonna make sure that we all understand the flow of everything, so you can kind of see how the wires go. You know, when I mentioned the other day about the tidbits about the length of wires. So I'm gonna actually do that. We're gonna do it on a radio. We're gonna actually look at, okay, that's just that distance between that dot and that resistor. Well, that might be a 10-inch wire. You know, that might not be right close to that switch. It might be somewhere else. So we're gonna actually see that. But I want to learn the sections first on the schematic, so you know what it is and where it's at on the radio, and what it does too, just like we did with the power supply. You know, kind of how it works. I'm gonna do my feeble attempt. There's many people way smarter than me and explain it way better, but I'm just trying to give you an overview of that, so you would understand why you're doing what you're doing on that and what it does. Ballpark what it does. As you learn, you'll understand this a whole lot more. I understand a lot more than I'm telling you because I don't know how to teach you yet on that. I'm still learning how to teach, but I wanted you to get this today. The main goal today is to see where B+ goes and how it feeds the radio, and then how it returns back into the can dome or to ground. All right, if you have any questions, you can reach out and I'll try to answer them as best I can. And like I say, I work a full-time job, so I might not answer right away, but I will try to read your question. I might try to answer on a video or something like that. I appreciate your time and thank you for watching today. Bye-bye. Well, hello. Hope you enjoyed today's video. Every time we do a little something, you learn a little bit more, and we're going to start putting all the pieces together. And when we get to the end of this, when we start on our radio, we're going to start from the beginning. You'll see how it flows one right after the other. But I wanted you to have some familiarity with the schematic and not just go into it blindsided. So I think next video we'll probably start on the sections of the radio. And I'll probably start at the front end, and we'll look how that signal comes into the radio, and how it fits on the schematic, and you'll understand where that comes from. So I hope you enjoyed today's video. Thanks for watching, and I hope you like and subscribe. Hit that bell. I appreciate it. Thank you.